Hi, my name is Cami Hale, and today I will be talking about the open area / box method for division. So this method requires us to draw a box or a rectangle. So our divisor, which is 4, will go on the outside, and then the dividend, which is 268, will represent this area of this rectangle. So we know that 4 is one of the lengths for this rectangle, and we want to find the length of this side. So this method allows us to break down the 268 by using bases of 10, because it's a lot easier for students to divide with using bases of 10. But by breaking it down, it's a lot easier and visually looks nicer. So if we try to do 4 times 100, we know that it cannot be this side length, because 4 times 100 is 400, which is bigger than what our area is supposed to be. But we do know that we can use 50 as one of the side lengths, as part of it. So we start with our original number, which is 268, and we subtract it using 4 times 50, which is 200. And now we're left with 68 as the area. So we still have 68 left of area that we need to cover with 4. So we found part of this side length. Now in order to find more, we start with what we last started off with, which was 68. And we know that 4 times 10 is 40. So we found another part of our side length, which is 10. 4 times 10 is 40. We subtract that gives us 28. So we still have 28 area left to cover with 4. So we bring it over here. And so now we know 4 times 7 gives us 28. Which gives us a remainder of 0. So this strategy works because when you decompose this problem, you are finding parts of the side length. It may not be all at once, but it still works, because when you add the numbers that we got by multiplying, so 200 plus 40 plus 28 gives us the original number, which was 268. So it works that way. It's just we did it by intervals or did it by part, and it still gives us the same answer. So our number is 67. So I believe this method is very good for students to see how multiplication and division can go hand in hand and that they're inverses of each other. So it doesn't work for the bigger numbers like these, but when we had 4 and 28, those are usually small numbers that students know from like multiplication tables. So in their head, they're saying 4 times what gives me 28. And so then they can create an equation where they can find it where 4x equals 28, and they're like, well, I divide it, and then they get x equals 7. So they can see that they're also inverses of each other, multiplication and division. I also think it's very good for the students to visually see how they're breaking apart this problem, whereas in the standard division method, they don't see what they're taking apart each time when they multiply it. So we're able to see like what we're taking away by multiplying it individually. So I think it's very good for students to visually see that. I don't think this method would work well with negative numbers, because you can't have a negative area or a negative side length. So it won't logically work, but if the student just ignore the negative until the very end, then that's fine. But I still think it's kind of taken away about like having a negative side length in a negative area. I do think it could get a little bit overwhelming if you had a big number, say like 6,500,000 something. Like if you had a big number like that, I feel like it would just be overwhelming to keep track of it all. But again, those visual learners might get the concept a lot easier than just the standard. So I think it's all about preference. Personally, I don't think I would do it, but I'm not everyone, and I'm not all the students. I don't think this method would work with polynomials, because with polynomials you can't really break it down when you have a dividend, whereas with this you can break it down with numbers. So I don't think this method would work for polynomials, which I also think would be a con for this method, because I don't think it can go farther than this. The numbers can be as big as they want, but when you include variables, I think that's when it kind of loses its strength. I do think that if you are given a length, one of those side lengths of a rectangle, and the area or perimeter of it, then you can find the other side by this method. So I think that's when this method might be useful for a high school education class.